All right, let's look at this question. How do you find the equation of the tangent lines to the polar curve? R equals 4 cosine of theta at theta equals 0. All right, so first thing we should try to do is find two pieces of information. So whenever you want the equation of a line, we need to have first piece is the point. Just one point on the line. So let's call this guy x1 comma y1. Right, and the second piece of information is the slope. Right, so let's call this guy m. Right, so let's see, x1, since we're using the polar coordinates, so x is going to be r times cosine of theta, and y is going to be r times sine of theta. So when theta equals 0, so let's try to find x1. Right, when theta is equal to 0, right, r with theta equal to 0, so 4 times cosine of 0, which is 1, so 4 times 1, so r is 4 when theta is 0, right? Then cosine of 0 is 1, so it's 4 times 1 is going to be 4. So x1 is 4. Right, so we're just finding the xy coordinates when theta equals 0. All right, then y1 is actually pretty easy because there's a sine of theta. When theta equal to 0, sine of 0 is 0. So this guy is actually 0. So r is again 4, but the times 0 gives you 0. So y1 is 0. All right. So at least we know that the tangent line has to go through that point, right? Now we want to find the slope, right? Slope m can be found by looking at the derivative of y with respect to x, right? But if you look at this polar equation, it's kind of hard to get that. So what we do is maybe we should do it with respect to either r or with respect to theta. I'm going to go ahead and do it with respect to theta. So instead of doing dy over dx, we're going to do a dy over d theta. You can do dr if you want, over dx over d theta. All right, so let's find the dy over d theta. So dy over d theta. All right. All right, so let's see. So you want to take the derivative of this guy with respect to theta. Remember that the r is a function of theta, so we're going to have to do a product rule. Right, take the derivative of r with respect to theta. So that's going to be dr over d theta, right, times sine of theta. So sine of theta plus, right, r times, leave the first guy alone, and a derivative of the second guy. So that's going to be a cosine of theta, right? And since we are looking at the theta equal to 0, so I'm going to just evaluate it at the theta equal to 0, right? So evaluate this whole thing at the theta equal to 0, right? So this is going to give you, let's see, you have sine of 0, so that guy is going to go to 0, so we don't have to worry about that. And here, cosine of theta, so this guy is going to go to 1, right? And you have a r. R is actually 4. So this guy is going to be 4. Maybe I should write that. So this guy is going to be 4. Right? So 4 times 1 So this guy is going to be 4. Right? How about dx over d theta? Right, this guy is going to be, so same deal. You have a dr over d theta, right? And the cosine of theta plus, right, r times, right, derivative of cosine is negative sine of theta, right? Then you evaluate it at theta equal to 0, right? So, but here sine of 0 is 0, so this whole thing is going to go to 0. Right, so this guy is going to be 1, and here this is dr over d theta, so it's a derivative of this guy. So derivative of r with respect to theta, maybe I have to do it here. So what's dr over d theta, right? So that's a derivative of 4 cosine theta with respect to theta, so that's going to be a negative 4 sine of theta, right? So that's this guy, but the theta equal to 0, sine of 0 is 0, so this guy is actually equal to 0 as well. So it's a 0 plus 0, so this guy is equal to 0. All right, then let's go back to the slope. So dy over d theta turned out to be 4 at theta equal to 0. And maybe I should be, so this is at the theta equal to 0. And here this is at the theta equal to 0, right? This is actually x equals 4, right? So x equals 4, right? And so this denominator is 0, right? Then we're in trouble. We have undefined slope. So this guy is undefined, right? Then what kind of line would have an undefined slope? Then we notice that, oh, this is going to be vertical line. If you have a vertical line, then slope would be undefined, because when you do a rise over run, run would be 0. So you have a 0 on the denominator, just like we have it here. All right, so this indicates that we're going to have a vertical tangent line. So it's going to be a vertical line. And we know that the vertical line would have a form of x equals a constant. But the x is going to be, since x1 is already 4, so we know that the x equals 4 is the slope of the, is the equation of the tangent line. So therefore, tangent line, tangent line is x equals 4. All right, so this is the equation of the tangent line. All right, so let's just make sure that we did the right thing. Let's use Geogebra here. All right, let's try to sketch this r equals 4 cosine theta. All right, so first I'm gonna go here, and theta is kind of hard to type, so I'm gonna use t instead. So r of t is equal to 4 times cosine of t. Then hit enter. All right, and we don't need to see this, so I'm gonna click that to hide it. And then we want the curve, so only way I know is to use the parametric equation. So we say curve. All right, then x is going to be r times cosine of theta. So it's going to be r of t times cosine of t, right? Then y would be r of t times sine of t. And then t goes from 0 to, say, 2 pi or something like that, right? Then hit enter. All right, so I'm gonna have to move this a little bit. So this is the graph of r equals 4 cosine of theta, right? Then we want to find the slope, the equation of the tangent line at 4 comma 0, because x is 4, so this is a point right here, so we can even put a point there. So 4 comma 0. All right, that's that. Then we want the tangent line that we found out to be x equals 4 is the equation of the tangent line. All right, so we have that. Looks like looks pretty good. So it seems like we have the right equation. All right, so this is just use the computer program to verify our result. Looks like we have the right equation. All right, so that's how you find the equation of the tangent line for this given polar equation. All right, that's it. I hope that this was clear.